So what is the CALIPRI measurement device? It's a profile measurement system for wear inspection of wheel sets and tracks. It allows the prediction of the wear behavior. It can optimize the maintenance cycles either for rolling stock, like for the wheels of a railway vehicle, or of the infrastructure, so for rails and switches. And it offers various parameters for rolling stock and infrastructure. If we have now a more detailed look on the CALIPRI C42, which is the handheld device, what offers the CALIPRI C42? This is the handheld device. It gives you all different kind of profile shapes and profile comparison. It's a multifunctional measurement device. So that means, we will see later on, then the hardware consists always on a tablet PC and on a sensor. And there can be different measurement modules put on the system according to your requirements. And there's a wireless data transfer. So after the measurement, the data can be exported and transferred in different formats into databases, or you can create PDF reports or whatever. So we will have a look on this a little bit later on. So what is the CALIPRI principle? What is the special thing on our CALIPRI systems? It's a fully non-contact freehand measurement. That means with the sensor, we are not touching the object. So we are not touching the railway wheel, we are not touching the rail. So that gives us the big advantage that the measurement is completely user independent. That means it makes no difference who is performing the measurement, we will get the same results. There is no impact on, I don't know, how you put or how much pressure you put on the object or whatever. It's completely independent. And you can imagine, if it's a freehand measurement, you have to be sure that the values are accurate, so that what you measure is really accurate. And therefore we have this special roll and tilt correction of the sensor. So that means as long as you move the sensor in a right angle and in the right distance over the object, the information will be captured, and from this information a profile will be generated. In case you perform the measurement not in a right way, you will get no measurement results, and the measurement will be aborted after a certain period of time, and you will get an invalid reading. So you can be always sure when you get a measurement result, it's an absolutely trustable, accurate measurement result. And it's one measurement instrument for many applications. I mentioned this already before. So the CALIPRI principle we had already, the all-in-one we had already. And what else we provide is, let's say, on the tablet PC, there are running two main software applications. One of them is called CALIPRI Manager, and the other one is called CALIPRI Portable Operator, CPO. The CALIPRI Manager is a software for generating the measurement plans. So normally at our customer side, we have one or two guys who are responsible of these measurement plans. So to create the measurement plans and also to take care that they always up to date. The CALIPRI Manager can be used in the office. So you have to do this work, or the main work you have to do once to create a measurement plan. That means you define all the measurement points, you set tolerances, you give the system the information how the measurement should take place. So further information like, I don't know, where is the rolling circle point from which the flange height should be calculated, and so on, and so on. So this, as mentioned, is a work you have to be once. And then in the daily operation, the operator is just taking the CALIPRI, open the specific train for that vehicle, for the fleet, and then he's performing the measurements under the train. And when he's finishing the measurements, he just is saving the measurements and probably export it or whatever. So he don't have to think under the train anything about settings and so on. So this is everything is pre-configured already. And the CALIPRI portable operator software, so the CPO, this is the real measurement software, what we will see later on in this webinar as well. So there you get then the actual measurements, and I will show you this later on. So here is a little bit more in detail the CALIPRI principle. You can see here an example of a rail and a railway wheel. So if we are starting with the railway wheel on the right hand side, you see that there are key positions defined. So for a railway wheel, there are 3 different positions, and the sensor has to capture these 3 areas to get all the relevant information and to finish a measurement. The sensor itself, so the measurement sensor, consists mainly of a camera and a laser. And we will see this in one of the next slides. So simply say it's only the laser lines are going on the wheel or on the rail, and the camera is making pictures how the laser lines are going on the object. So for our customers, the CALIPRI and the CALIPRI principle offers many advantages. It's not only the measurement process itself, which is very easy. We'll demonstrate to you later on in a live measurement how easy it is to capture a wheel profile, but it improves also the complete workflow. So as I said, with this CALIPRI Manager software, the measurement process, and then transferring, exporting the data, the whole process, the whole workflow into the workshop can be improved with the system. Another advantage is that it's only one device, so you always have the tablet and the sensor. There is, for other kind of measurements, no extra equipment needed. We have for some of the modules, like for the diameter, for example, or the back-to-back distance, we have some helping gauges that comes with the measurement module. So this is one package, but you don't need really an extra measurement device or measurement equipment. When we have a look on the rail, we see there are more positions defined. So we're concentrating here on the rail head, and you really have to measure under the rail head, and then you follow the complete rail head to the other side. We need also the underside of the rail, because this is for the system, the reference. This is a non-worn area, and on this area, the rail will then put into the coordinate system in the measurement software itself. So here we have a look, overview about the other application, what we are providing with the CALIPRI C42. So the wheel profile, we will have a look more into detail today. Additionally, we can get the wheel diameter, the dia thickness, the brake disc, wheel defects, and radial and axial runout, as well as the back-to-back distance, so between left and right wheel. So you see there are a lot of measurements on the wheel set regarding maintenance, wear behavior of the wheel set. So this is what we are dealing with. With the same system, it is also possible to measure in the infrastructure. And for the infrastructure, we have the modules rail profile measurement, a switch measurement, as well as track geometry. So these are here the main applications. And then additionally, we are providing some external software if you are interested in further analysis of the data. So there's one system called one software called CALIPRI Analyzer, where you can do by hand some calculations of distances, angles, and so on. And we can also get the equivalent conicity, so you can check the rail wheel contact and behavior. You have in this program different possibilities to compare real measured data with each other or compare it with norm data. So now we will have a more closer look on the measurement module wheel profile. I mentioned this already before. More or less all of our systems are delivered with the wheel profile, so that's always the basis. And then the customers have some other requests, what else they would like to measure, but the wheel profile is always part of the system. Here you have again these two software packages with a more detailed look. I don't want to say too much about it because we had it in a more discussion already before, and the CPO we will see then in detail on the screen when we do the measurement. So now I would like to give you an explanation how a measurement happens, so how this is working. As mentioned before, freehand measurement. Therefore, you need probably in the beginning, you need some guidance, and we have some helping tool which guides you through the measurement. First of all, there is a visual tutor which will be shown in the software on the tablet PC. You can see on the picture the wheel profile. And you see with these sensor symbols, there are 3 in total with yellow, green, and orange. And the black one is my actual sensor with the measurement field. So you can see this is very good. You can see, or you have to imagine, the measurement itself happens a little bit like if you would like to inspect a wheel profile with your eyes. So you look around and you check the profile, and the same thing happens here with the sensor. So you see the black position, my sensor, what he sees at the moment. So this is the blue line. So it's capturing a part of the wheel flange as well as the outer side of the wheel. And we need for all 3 key positions, we need enough data. Enough data means everything must be green. If it's green, there is enough information so that the system can set a profile together. In our case, we see at the top of the flange, we see already an area which is already green. So I guess also, or I assume for the flange and for the outer side, this will be also more or less enough. And then we would have to move with the sensor to the inner side of the wheel, so to eliminate also this red area. And if all sectors are green, these sensor symbols disappear. So all 3 of them will disappear and the measurement will finish. So to summarize, blue is the current position, red is we have no data, yellow, which you can also see a little bit on the top of the flange, is we have few data but not enough to set the profile together, and green means we have already enough data. So this is one of the helping tools. Then we have also some sound signals. So you will hear them later on when I will perform a measurement. You hear a click, And this click means that I'm in the right position and in the right angle to the wheel profile, and the system is gathering information, and with this information it will set the profile then together. When one of the key positions, one of the 3 key positions finish, you also hear a ringtone so that you know, okay, this sector is done. This is the sound signals. Then we have speech signals, which gives acoustic information where you are in regarding the measurement. So if you are too close or too far, if you tilt the sensor, or if you have to turn it left or right. To be honest, this is a nice gimmick during a presentation, during a demonstration, and it was in former times when the CALIPRI system was not so fast. It was quite good, quite helpful. Nowadays, I must say, due to the really speed and of the measurement and how easy it is to capture a profile with the CALIPRI, these speech signals are not really so helpful because it's always a little bit behind the real actual position of the sensor, and therefore most of our customers are not using this feature because it's also getting a little bit annoying after a while when you're performing some measurements and you hear always the voice. And more important, and for me, really I would say the most important guiding tool is the vibration function. So also for these 3 key positions, when you have enough information and when one of the key positions disappear, you feel a slight vibration in the sensor, and that gives you the information, okay, this section is finished, I can move to the next one. And if you feel 3 vibrations, you know, okay, the measurement is successful and done. And then you can just have a control look on the sensor and you will get the results. So most of our customers with some experience are only using the vibration function because the rest is not really needed then. So now let's have a look how a measurement really is working in detail. So we have 4 different steps. You see on the top on the left side, this is the recording of the data. So you guide the sensor around the wheel profile. We have this automated tilt correction. And as I mentioned before, the sensor itself has no processing capacity. So it consists only of the sensor and of the camera. And it is connected with a tablet with an internal Wi-Fi connection. So what happens is the camera is making pictures of how the laser lines are going on the wheel. You see this number 2, the rotator. So these are, you can call it single pictures, segments, whatever, rotator. What the camera sees, so how the laser lines are going on the wheel. And this rotator will be transferred via this internal Wi-Fi connection to the tablet, to the CPO, to the measurement software. And the software is merging from all this rotator, merging the profile curve. So this you see step number 3. So we see here already the profile curve. And the CALIPRI system is taught to recognize a railway wheel. So it gives out then the most important wear parameters. So this is then step 4, calculation of the measurement values, based on a chosen evaluation strategy, and an automatic classification tolerance ranges. This can be done or will be done also already in this CALIPRI manager software. So when you creating the measurement plan for your vehicle, you can set tolerances already for each parameter. And when you perform then a measurement, you will see each of the measurement values then in regards to the tolerances. This is a color code system. So you can, for example, define green as the parameters are in range. Yellow, it's critical, and red, for example, it's out of range. And you can see really for each single parameter is if one of the parameters is critical or out of range. And when you go to the complete picture of the measurement plan, so for the complete axle or for the complete boogie, you can see it also for each measurement point. So if one of the parameters is out of tolerance, the complete measurement point is getting red. And so when the data will be then analyzed or exported or whatever, you see immediately on one glance on which wheel you have to do something, if you have to reprofile it, or in the worst case, if you have to change the wheel. When we come to the measurement methods, we have 3 different measurement methods for the wheel profile. The biggest one on the top, the measurement wheel profile, is what I mentioned before, complete profile of a railway wheel with 6 most common wear parameters, which meaning flange height, flange width, QR, so the slope of the flange, a hollow thread on the running circle face, if there is one. Then if there is any move out of material, we also detect the rollover, and you get the total width of the wheel. For some customers, they say, okay, for us, the total width is not so important. We are just fine with the wheel flange. In that case, of course, the measurement process is even simpler. You have only 2 key positions, which is the inner side and the flange area. And you get the 4 parameters: flange height, flange width, QR, and hollow. Total width and rollover won't be shown in this method. And the third one is the double flange wheel profile, which will be used, for example, for grain wheels. They are running on double flanges or some other applications. What I forgot to mention before, if you, for example, are familiar with other similar or measurement equipments for checking the wheels, what is also special for the CALIPRI is that we don't need a reference profile to getting a measurement. So these are really absolute measurements. So if we have a look on the flange height and flange width, for example, these are absolute values in millimeter, so, or for the US in inch. We don't need to have the norm profile to give out these parameters. So you don't have to select a wheel type. This is not necessary. Absolute measurement and getting the result. If you would like to compare it with a norm profile, you have the possibility, what I will show you later on in the second module we are discussing today, in the profile compare. So there you have the possibility to compare an actual measured profile, either with a standard wheel profile, or, for example, with an older historic profile of the same wheel. So to do some further analysis about the wheel wear. So here a little bit more in detail, the different kind of other parameters, what you can get with the wheel profile method. One of the advantages of the CALIPRI is also that it's a profile measurement system. So it's a profile measurement system used in the railway industries, but it's not really only, let's say, connected to the wheel or to any other object. So that gives us the possibility, we capture the complete profile. And if there are any other parameters to implement to show yeah, it can be done by us. I have one example in Japan where some of the customers are not using the QR for getting the slope. So they have something they call flange angle. And so we implemented for this Japanese customer the flange angle and yeah, remove the QR. So this is also possible. So the system can be adapted to your requirements, to your needs. When a measurement is done, you have different possibilities of how you proceed and process the data. So you can either print out a report. We have some predefined reports on the CALIPRI, starting with a simple table report with all the absolute parameters, up to very detailed reports which are showing you the profile curve, the data, as well as the tolerance classes, so you can really see how close or how far you are already to your critical points. So there are different reports available in the software already pre-installed, so you can use them if you're using the system. And we have different possibilities of exporting the data. So mainly it's XML and CSV format. So if you are using already an existing database or a predictive maintenance software, almost all of these systems can cope with either XML or CSV data. We just provide the data and then they can be implemented or can be integrated into the software so that this data can be saved there. We are also providing our own software solution, which is called CALIPRI Predictor. This is a cloud-based solution for storage and also for the prediction lifetime of the wheels. This can be, you can see the data from everywhere. As I said, it's a cloud-based solution, so you have access from everywhere. You can store the data there, and you can also check about optimization of your maintenance cycles and behavior. And additionally, we offer the possibility of exporting the data in DXF format. So if you use any kind of drawing programs like AutoCAD, for example, you can export the profile curve and load it then in DXF and do some further analysis there. So this was the wheel profile measurement. We will have a measurement then later on, but I just want to finish up the presentation with the second module we want to discuss today, and this is the measurement module profile compare. So the profile compare allows a quick analysis of wheel or rail wear. Due to a comparison of a worn wheel with a standard wheel model or a previous measured profile, you can immediately see visually where you have the deviation, where you have the wear on the profile. It will give you these errors to see where the wear is happening. And additional, with the mouse, you can also get the absolute values, how big the deviation is on one specific point. And this can be done, of course, either for wheel profiles as well as for rail profiles. So how does this work in detail? I don't want to show it here because we will at the end I will show you this in the CALIPRI software itself, so you can see how this is working there. Here a little bit more closer look on how the profile is looking into the measurement software. First for the wheel profile, and here for a rail head. So this is more or less what I would like to tell you about the profile compare feature. It's quite a simple but very effective tool. And at the end of my presentation, I would like to point out that we have a special gift for you, let's say. So for everybody who is joining the webinar, we have a special deal. So if you are planning of purchasing a CALIPRI system in this year, you will get a special promotion, a special discount. So that means if you buy 2 measurement modules, so I told you before, basis is always tablet and sensor, so the hardware, and then the different measurement modules, what we have seen in one of the slides before. So if you purchase in total 3 modules, the third module will be discounted by 2,024 euro. If you are planning a bigger scope, so if you would like to purchase in total 6 modules, we will deduct this 2,024 euro for the 5th and the 6th module. So to sum up a discount of in total a little bit more than 4,000 euro. And additionally, you get a free license of our database prediction software, CALIPRI Predictor. Get the license for 6 months for free. Important is that these orders and deliveries will be completed within this year, so within 2024. So therefore you have to be quick in case you order, let's say in the 1st or 2nd week of December. It's of course also no problem. Our production is quite fast, and they will be able to deliver the system within this year then also. So this was at the end, this webinar promotion. And now I would like to go to the CALIPRI system and perform a measurement. So you see here the CALIPRI sensor. So sorry, I have to close the presentation. So you see here the sensor with here the laser lines which are coming out, and here the camera. The camera looking in a special angle on the laser lines, and how the laser lines are going here on our wheel profile model. If I would like to perform a measurement, I have here on the left and on the right side a button. And when I would like to start a measurement, I just press the button, then I go off the button, and then the measurement is starting. Here we have the tablet PC, where I have already started the software. More of the software features I'll show you later on then on the screen. Here it's just for making the measurement happen. So as I said, when I would like to perform a measurement, I press the button, and then I just follow. I go around, and you see here we get the profile curve with the wear parameters. So takes only a few seconds for the measurement, and then another few seconds for the evaluation of the data. So you can see in a few seconds you have the complete profile. I would like to demonstrate you now this special tilt correction, what I have told you also before already. So if I start a new measurement, you hear this click, and this click means the system is capturing information. I'm in the right angle, I'm in the right position. If I would tilt the sensor, you hear tilted and the click disappear. So this information will be thrown away. If I go back to the right angle, you see, after a certain period of time, if I have tilted the sensor too long, the system reports the measurement and say, okay, I not have enough data, I cannot finish the measurement, and of course you get invalid readings. So this proves, as I mentioned before, as long as you measure in the right angle, in the right position, you will capture enough information for the system to set a profile together and give out the wear parameters. So you can always be sure when you get a result, it's an accurate result. So once again, you see we have finished the next measurement. I told you for its kind, not really well experienced, even after a certain a short period of time, when you use the system, you will only use the sensor. The tablet can be stored with a belt system safely, so that it's not disturbing you when you go under the train. But the main operation happened here with the sensor. You see here we have also a display. And I have here all the measurement points. So I can also flip here to the different measurement points. And if I would like to see, so wheel profile, for example, I can click in and you see you get here the same information from the absolute values, what you see on the in the software on the screen, you see here also on the sensor. And you see the color dots next to each of the parameter. So these are the tolerances. So you can also see here on the sensor already if one of the parameters is in a critical stage, if it's okay or if it's out of range. So from the work procedure, the operator is doing the measurement. He's feeling the 3 vibrations of the sensor. He has the information, okay, the measurement should be successful. So he just check at the sensor if all values are here, if the measurement is okay, and then he's moving to the next wheel profile. So this is a very quick, fast, and easy process of checking the wheel profiles. So, and then at the end, okay, just. So we have two questions. Okay, so there is a question if you can install our software on another tablet or another PC or whatever. Unfortunately, this is not possible. So for us, the combination is always our Panasonic tablet with the sensor. This has 2 reasons. I mean, first of all, because of this internal Wi-Fi connection, the sensor and the tablet always has to stay together. So the Wi-Fi connection is approximately 10 meters. So you have to carry the tablet with you, or at least have it close to the point where you're doing the measurements. And on the other side, we don't want to have other softwares running on a laptop, on a PC, on a tablet, because we are afraid that there are some interferences or turbulences, so that one software has impact on the other, and so therefore, yeah, a CALIPRI C42 is always the combination, our Panasonic tablet PC, where the two software programs are installed in combination with the handheld sensor. Then there is another question about exporting of the data. I'm quite sure that this is working, but I will have a discussion afterwards, and I will come back to you. I think this should be no issue. I mean, our customers are using so many different databases, and there are so many requests of getting the data into the software. And honestly, so far we were never facing bigger issues, bigger problems. So I'm convinced, and I'm quite sure that this will work. Yeah. Mm-hmm. Yeah, so then there is another question of the export. I can show you Sigma software. So you have here, when you go to File and Settings, you have here a lot of default settings for the different formats. So if you have CSV export, XML, profile, and so on and so on. So you can already here in the settings do a lot. This specific case, yeah, I will follow up and I will come back to you. I don't want to say something wrong now, because honestly I'm not dealing too much with this export schema in detail. So I have to ask one of our guys here. But I will answer you this after the webinar. So here a little bit more in detail, you see how our software looks like. So this is a wheel profile, how I performed it on the wheel profile before. You see here we have a plan view. So this comes from the CALIPRI manager. So when you predefine a measurement plan, you can select also a picture of an axle or of a bogie or whatever. So in our case, it's an axle with 2 brake discs. And then all the different measurement points are defined. Wheel profile, diameter, clearance, and the brake disc. And on the left hand, you see the complete list of the different measurement points. And you can just select either on the sensor or here in the software what you would like to measure. Here you have also some fields for identification, so vehicle ID, mileage, user. These are also completely can be configured to your needs, so this can be done by you. Also in this CALIPRI Manager software, this information will be also, for example, printed out then on the PDF report. So there you can just write in what you would like, what information you would like to have about the vehicle, about who is doing the measurements, and so on and so on. So this is also the possibility. As I said, here is the plan view, and here is the profile view with the 6 wear parameters. What I not told you before is you see here a purple line. So this is for the CALIPRI, the reference how the wheel profile is put into the coordinate system. So we are looking for a not one area, which is in many cases, not in all, but in most or in many cases, it's the inner side of the wheel. And the purple line is really in this area, the software is looking for a straight reference. In case you would have somewhere here, you can shift this purple line very easy to the top or to the bottom and create then a straight reference. So if in this area would be no straight reference, you will get not valid results. So there will be invalid readings. And if you shift then the purple line, there is no new measurement needed. So it's only a recalculation. And the system looking for the straight reference, if it's finding the straight reference, for example, maybe in this area here, it will give out then the where parameters. So that's for the wheel profile. If you would like then to export data, so you have, for example, here reports, the PDF report, or to export the data in one of the discussed formats, you can save the data here, and of course you can also load some older data. When we are going now to the feature profile compare, I click here on profile compare. I activate our profile compare, and I have to tell the system, okay, I need another profile for comparison. So you can have either an older exported wheel or a CSV file of a standard wheel profile, and you can select this in this specific folder. You just load this profile, and then you see that these two profiles are overlapping. I'll just make it a little bit bigger. So you see this here. It's of course not, we see here I did this now, of course, for the demonstration in a very, let's say, bad way, let's say, so that you can really see it very good. And if you activate the deviation plot, you see, as mentioned also before, this is maybe a little bit too much. So let's put here 2 maybe. So then you see here also from the length of these red stripes where the wear happens. And as I told you before, you have here with the mouse, you have here the ruler, and it gives you here also the absolute value. So if you go, for example, at the top of the flange, we see here, okay, the deviation or the wear behavior in this area is 3.19 millimeter. So there you can also get some absolute information. And you can also save this then. You can also create already a complete template. So if you have a standard norm profile, which is then in CSV format, you can make this as a template, and then you can only load it, the template, and it will compare then each actual measurement with this template, and you get immediate feedback about the wear behavior. Good, so this is what I wanted to show you about the profile compare. And so I'm at the end of this webinar, of this introduction of the two modules. As I said, the intention or the aim from us was really to give you a brief overview. I hope there was some additional information. I know, of course, that almost all of you know already the CALIPRI equipment, of course, but I hope it was for the one or the other either a good repeatability for getting the information back, or even some new information. I don't know if there are any other questions.